In this video, I'm going to talk about how to turn this statement here, which is not in the form if P then Q. I'm going to talk about how to turn it into a statement of the form if P then Q. All right, so thinking about P implies Q, or if P then Q, remember that these are the conclusions and this is the assumptions. So this statement here, the sum of an even integer and an odd integer is an odd integer. It can be formulated in this form, P implies Q, if P then Q, but right now it's definitely not in that form. So one of the conclusions is the conclusion is going to have to do with summing or adding an even and an odd integer. So the assumptions, let me put these in red. The assumptions are that we have an even integer and an odd integer. And then the conclusion is that when you sum those things, you get an odd integer. So something like that. They sum, the even and the odd integer sum to a new odd integer. Right, this idea kind of gives us a sense of how to write this as an if-then statement. All right, so the assumptions are that we have an even and an odd integer. So one first formulation might be something like if you add, or if you sum, you could replace add with sum. If you add an even integer and an odd integer, then you get an odd integer. Now notice how this says basically the same thing. So I've written the same thing twice. If you add an even and an odd, then you get an odd. This basically says the same thing as what I started out with. The sum of an even integer and an odd integer is an odd integer. But still it's somewhat difficult to prove. So a better formulation, I believe, would be something like if x is even and y is odd, oh, maybe I should put an integer here. If x is an even integer and y is an odd integer, then x plus y is an odd integer. And now this final form here, now we have a handle on, we have a name, right? This x gives a name for the even integer. This y gives a name for the odd integer. It gives it a name. And then x plus y is this new odd integer. It gives that a name, x plus y.